as the fixed biasing circuits. Applying KVL at the output, VDS is equal to VDD minus IDRD, VDS is equal to VD minus VGS, and VGS is equal to VG minus VS. So that source terminal is at the grounded potential, so that Vs is equal to 0, VDS is equal to VD, and VGS is equal to VG. The graphical analysis. How we shall analyze graphically the FETs? Here the transfer curve for the FET is drawn from the given values of the saturated drain current IDSS and the pinch off voltage. IDSS is saturation drain current, P it is the pinch off voltage. By using the shorthand method, a straight line is drawn from the by using shorthand method. A straight line is drawn from the point VGS is equal to minus VGG. A straight line is drawn from here, it is a VGS. Here the transfer characteristic FET is drawn from the given values of IDSS and the VGS. IDSS and VGS. Here the IDSS saturation current. By using shorthand method, a straight line is drawn from the point VGS is equal to minus VG. Here it is the VGS, it is negative values, and here it is drain current ID, it is in the milliamperes. So that a straight line is drawn from the point VGS is equal to minus VGG. Here this one, that line intersects the transfer curve at point Q. That curve it intersects, because by shorthand methods we will be getting this is the one point and here it is the other point, and this one, if you join these 2 points, it is the transfer curve for the FET, and a straight line for the biasing circuits. For the biasing circuit is shall draw another straight line, that is from VGS is equal to minus VGG. Here it is a straight line is drawn. That line intersects the transfer curve at point Q. This point is known as the operating point or quotient point. That point gives the this point. This point it gives the that quotient point. The point gives the quotient values of drain current ID and gate to source voltage VGS. Determine the following for the network as shown in the figure, that is VGSQ, IDQ, VDS, VD, VG and VS. Here this one, it is a fixed biasing circuit. This circuit, it is a fixed biasing circuit, so that because a fixed voltage is applied at the input, a high gate resistance is applied at the input, that is RG is equal to 1 megohms, here RD 2 kilo ohms, and IDSS and VP it is equal to minus 8 volts. This one, it is a fixed biasing circuit. The given circuit is a fixed bias circuit. So here we shall go for the graphical methods, so that instead of going directly for the mathematical analysis, a graphical analysis can be done here. Here VGS and here it is ID, and the IDSS upon 2, IDSS upon 4 and 0. VGS it is 0.3 Vp, 0.5 Vp and the pinch off voltage. From these graphical methods, VGS will be getting the values when VGS is equal to 0, ID is equal to IDSS, and VGS is equal to 2.4, that is 0.3 Vp, ID is equal to 5 milliamperes, VGS is equal to 4, ID will be getting the half 1 by IDSS upon 4, 2.5 milliamperes, and VGS is equal to 0. Now from those we will be getting the transfer characteristics of these parameters. Here it is 10 and here it is the 10 IDSS, and here it is the VGS is equal to VP. From that transfer characteristics is drawn, and a VGS is equal to minus VGG is equal to minus 2 volts. Here a minus 2 volts, that is a fixed voltage is applied at the input. This is the biasing voltage for the fixed bias circuits. Now the intersection of the transfer curve and the network curve, that is biasing curve, gives the operating point. Here this is biasing curve and here it is transfer curve, so that the intersection of these two, it is gives the that gives the operating point. Now from that one, if the straight lines are drawn, the horizontal lines and vertical lines are drawn, so that these will intersect the VGS and the IGS ID axis at these 2 points. Those will give the IDQ and VGS, quotient values of the gate to source voltage and the drain current. The quotient value of gate to source voltage minus VGS is equal to VGG is equal to minus 2 volts, and the quotient values of drain current, it is equal to 5.6 milliamperes. So that if you draw these characteristics curves in the graph sheets, then you will get the exact values of the quotient values of drain current and the gate to source voltage. IDQ is equal to 5.6 milliamperes. VDS is equal to VD minus VS, so that here we have to determine VDS is equal to VDD minus IDRD for fixed bias circuits. VDS is equal to 16 minus 5.6 as 320 VDS is equal to 16 minus 0.2, VDS is equal to 4.8 volts, and VD is equal to VDS plus VS, VS is equal to 0 volts, VD is equal to VDS is equal to 4.8 volts. VGS is equal to VG minus VS, VGS is equal to VG is equal to minus 2 volts, and source voltage and voltage at the source VS, it is equal to 0 volts. Voltage at the source is VS is equal to 0 volts. So that from that one you will be getting the different, that is the all the parameters of the fixed biasing circuits can be determined.